All right. Well, welcome everybody on this wonderful Friday afternoon. I hope where you are it's sunny and warm out, as it is where I am in Vermont. And I wanted to welcome all of our Brownies who are joining us on the Girl Scouts of the Green and White Mountains Facebook page for the third of 4 classes for your Space Science Adventurer badge. We're excited to be with you today. Of course, you can always watch the other classes if you happen to miss them and do the handouts that you can download, but you can find all those materials on the same Facebook page you're on today. In a moment, I'll turn things over to our excellent teacher, Hannah Buckner. First, I just wanted to mention to you that if you're on the Girl Scouts of the Green and White Mountains Facebook page, you'll notice that you can chat and ask questions there. And we just ask that you include your name and your location in any questions you ask. You can just do your first name. And that way, we'll be able to answer them both during our session today, and we'll also set aside some time at the end to be able to answer your questions while we're still live with you today. And other than that, I just want to welcome you all for joining us today. We're excited to be doing this class. We are, of course, myself and Hannah are at the Fairbanks Museum and Planetarium in St. Johnsbury, Vermont, and we're excited to partner with the Girl Scouts on this. So I'll turn things over to Hannah now.
Great. Well, thank you, Drew, for that introduction. So welcome everyone to the third week. Oh, why is my video off? Thank you, Drew. So yeah, welcome everyone to the third week of working towards your Space Science Adventurer badge. I know you've been working very hard to, go along with that and learn a lot about astronomy. And so first, I just want to review. I want to review kind of what we talked about last class. And if you have any questions, please let Carrie know on Facebook, or maybe you can reach me later about that. But so in the last class, we talked about telescopes and binoculars and the different types of telescopes, and how binoculars were like a certain type of telescope, and how we talked about how light can be bent or reflected, or meaning light can be bent or refracted, or it can be reflected, and that can change how clear something is, and depending on how wide a lens is, or the telescope pole where the light can come through to hit a mirror, that can change the power or the size of the magnification that an image has. And so that was something that you were doing on your handout, where you were going to be playing around with a few different simulations. And yeah, I hope that was something that was really informative and fun to do, and something that was just helpful to see the application of what you learned in an actual working. So yeah, I hope that was useful. And then, sorry, I'm just pulling up the assignment to see if there's anything else. Yeah, so if there's any questions about light, or how telescopes work, or the difference between space-based or land-based telescopes, I'll take those now. And I'll give you kind of just a minute to think about it if you have any questions. So I will be letting you guys think about that as I move forward into the next part of our class.
Yeah. And just a reminder, if you want to ask those questions on Facebook, just include your name and your location, and we will get to them as we see them sent over to us from Facebook. Thank you.
Yes. So while you guys are thinking about that, I'm just going to set up our thing that we'll be using today. So the class that we're going to be focusing on, well, the topic that we're focusing on today in class is the moon and the different phases of it. So we'll be talking a little bit about the geography of the moon, what we can see when we are looking at it, and then we'll also be jumping into what the phases of the moon are, or why the moon looks different at different points in a month or throughout the year. So, and there's some really cool simulations that NASA has on its website for the various planets and their moons and other stuff. So that's what we'll be using today. Yeah. So if there are no questions, we can move forward. So I will, where is it? There we go. Okay, so I'm going to share my screen and bring it over to the moon. So what is this doing? Oh, sorry guys. You can't see it, but I can see it. It's Zoom is being a little tricky. Okay, so the moon, our lovely natural satellite that we see in the night sky and during the day when it's reflecting light off of its surface, just like with telescopes and certain types of them, light gets reflected off of the surface and it jumps back to us. And so that allows us to see the surface of the moon because there are some more reflective spots than others. The darker spots are not reflecting as much light and they're actually absorbing more color. So it seems a little bit darker than the other. So what you're seeing are brighter spots here, and then there's like all these darker spots, and then sometimes there's these areas here, and it just looks like a very rocky, not really flat place. And so why is this something important for us to be looking at? Well, the moon is actually the only other place in the world that us humans have actually been on, that we've walked on, that we've studied up close and personal. We've sent we've sent robots to Mars, but you know, we haven't actually been there ourselves. We haven't done physical research that can really be done that makes it easier to understand or to look at, because we do like to do research with our hands if possible, and to study things. So if we want to look at like parts of the rocks that are there and like what's in them, what tells us about the history of that rock, we can't necessarily do that with our hands if we're on Mars. So when we're on the moon, we actually did collect samples and brought them back here. We have a lot of it because we had many missions to the moon. There were actually 24 human visitors and 12 moonwalkers. So from those 12 people, we actually did bring back some really valuable information about our satellite, which is the moon. And so you'll actually notice that when we're talking about the other satellites of planets, we call them moons. And that's because we were like, oh, they have what we have. We have this natural satellite that is pretty big, but not like the satellites that we send off into space that can give us cell signal and Wi-Fi and TV and studying the atmosphere. This satellite is very big. It's actually about a quarter the size of the Earth, but all these other planets have them, and so these are the moons. The moon is actually very similar to the Earth, where it has a core, a mantle, and a crust. And so there's an inner core, and then there's an outer core, and that is this area here. The inner core is really dense and it's full of metal, and it's mainly made up of iron and nickel. And then the outer core is partially melted. It's more of a fluid. So it's like water, not water, but like how water moves. That's what the outer core is like. And then you have the mantle, which just like here on Earth, the mantle is very dense or packed together with minerals, with different types of well, minerals and metals. And back when the moon was formed, it actually had lava in it. And so that's actually quite important to talk about what's on the crust, or this like outer layer that we actually see. So the moon used to be active like the Earth, where the inside was very hot and had lava and actually had volcanoes. And so one cool thing to know about the moon is that these black spots actually didn't used to be there. These spots were they were very deep, actually. They were like the valleys that we see here in Vermont. But all of these little white spots, I don't know if you can see them very well, just because I can't zoom in. But these things too, those were actually volcanoes. And so when they erupted, they actually, all of these basins filled up, kind of like your bathtub. When you fill it up with water, it becomes flat. These basins filled up with lava and then they cooled. But because the materials that were made up of that lava were different from the crust, it actually is a different material, so it's a different color. And so you'll actually also notice that this whiter part has a lot more impacts on it. So you'll see a lot of this impact cratering on the wider parts, but not really on the darker parts. And that's because they formed either before or maybe slightly after all of these lava lakes filled in. And so as the lava lakes filled up the basins and cooled off, the darker parts, which we call seas, or Maria, which is a really easy way to remember. It sounds like a name. It's actually Latin for seas. So the Lunar Maria are the black basalt lakes that we see. And so they're actually much smoother than the white parts. But you know, some of them did hit afterwards, and so you see some of the impact of like the dust coming out. And that's actually how we can tell where certain things are on the moon, because you'll see that there's where is it? We do name them basins, but I guess we don't have out there. So the Mare Oriental is one of the many Maria that we have. So a singular sea is called a mare, and just like a female horse. But you can also see where we had human landing sites and robotic landing sites. A lot of them actually were near the Maria, if not on the Maria. And so that can actually tell us where things were. But another cool thing about these Maria is that sometimes they go away, sometimes they don't. And so what we're going to see is with the lunar phases or the moon phases, they come and go. They don't actually really move. But we'll see how they kind of come and go with light. So let's get started on that. So today, April 24th. Is it April 24th? I feel like it is April 24th. Yes, it is. It is April 24th. We have a new moon, or it says waxing crescent. But it looks like we'll be hitting the new moon soon. So, or we have just come from a new moon. What does that mean when I keep saying new moon? Well, when we look at the sky and there doesn't seem to be a moon in there, the moon is always in the sky, but when the moon is actually behind the Earth, in its path around the sun, we actually can't, or no, sorry, when we are behind the moon on our path around the sun, and I'll show you what that means in just a second. We actually don't see the reflected side of the moon because it's actually blocking out light. So as we go through the cycle, it actually appears dark. And then tomorrow we'll see this little sliver of light. So it's becoming bigger. When we're saying that the moon is becoming brighter from a new moon, we call it wax. If you're adding wax to something, it's actually getting bigger. So if you keep dipping think about if you're making a candle or you're dipping your hand in wax, the more you dip it in wax, if you're waxing it, the thicker your hands are going to get. So there's becoming more light. And so we're seeing 25, 27. So in 3 days from now, we'll actually see that it keeps getting bigger. And we call this a waxing crescent because it looks like a crescent, not a croissant, though a croissant does look very similar. It has that curved shape to it. And as we get a little bit bigger, we've reached the first quarter of the moon. And what does that mean? Like first quarter? Well, we don't say, you know, the half moon, because the half moon is, we'll see in a second what that is. But, and it's not really a quarter of the moon that is lit up. We're just saying it's a quarter of the moon's phase has actually passed. And so there are 4 quarters, which 4 fourths makes up 1. So if we've done 1/4 of a phase, we've got 3 more to go. So it's not that 1/4 of the moon is lit up. It actually, 1/2 of it is actually lit up, because you'll see if we turn it. No, I can't do it. 1/2 of the moon is always lit up. But if we go back to the moon phases, stop it. So we've reached the first quarter, and it keeps getting a little bit bigger until we reach a phase called the Waxing Gibbous. So they're really weird names. A gibbous means that it's not completely full, but it's just there. So there's actually, instead of a waxing crescent, it's almost like a waxing darkness, because you'll see that here is like a sliver of a crescent that is a shadow. So the light part of the moon is not fully filled, but it's on its way there. So that's what a waxing gibbous is. And then we reach the full moon. And so one full lunar cycle is about 30 days. And so we've gone about 15 days into the cycle. And so it'll be like this for a little bit, for like a day. And then on May 7th, it'll start to be a waning gibbous, which means instead of the gibbous becoming bigger, it's actually getting smaller now. So it's going towards the 3rd quarter of the moon, which is when the light on the moon has reached the other half. And then it keeps, the shadow gets bigger and bigger until we've reached a waning crescent, or the getting smaller crescent. And waning means getting lesser. So it fits, and then it's gone. And then we have a new moon all over again. And so it repeats. But we know that this isn't just light disappearing or something. It's actually, it has to do with the way that the moon and the earth are in position together, or how they're related to each other as they're going around the sun. And so I'll go through this phase really quickly on here, but then I'll show you what it actually looks like on another simulator. So it gets brighter and then it doesn't. So let me pull up what was it called? Okay. Well, while that's pulling up, here we go. Does anybody have any questions about the phases? And before I answer any questions on that, what you might have, I'd be happy to answer them as we're waiting. Well, okay. I don't think it's gonna. Okay. So I'm going to do a new share. And we'll do this. So, Drew, can you just confirm for me that you're seeing the solar system?
Yep, we're seeing it perfect over here.
Great, okay. So this is, let's do this by night. So we're gonna look at this about 12:30. Actually, we'll do 10 o'clock. And then we'll just go by day. Okay. So right now is when we're seeing a new moon. So this isn't actually like exactly right. So, well, if we're looking at a new moon and we're looking this way, that's when the moon is going to appear dark because it's actually pretty close to the sun. And then here. It's confusing. Okay, that's fine. Okay. So now you'll see at the same time the next day, it's further. So now the sun is shining on a little bit of the moon from our perspective. So now we're seeing, I wish I could do this back and forth. Now we're seeing, okay. Now you should be seeing this little sliver of the waxing crescent. So the light's becoming bigger. If we go to 2 days, like on the NASA website, you'll see that I got a little bit further. So now it's continuing to get bigger. And then, Drew, just want to confirm one more thing. Are you seeing me switching between the NASA page and the solar system page? Oh, great. So I don't have to keep doing that. Wonderful. Okay. So yeah, we went to the 27th. And if we go to getting the first quarter is the 28th. So we'll go to the 28th. And it's getting a little bit further this way. But the first quarter really reaches the 29th. So we're going to go to the 29th, and you saw that it jumped. And so we're seeing that 1/4 of the orbit actually around the Earth has been completed of the moon. And so when we go to a waxing gibbous, which is on May 2nd, now we can't even see the moon on this section. We actually have to turn it this way. And so you can actually see from this perspective what the moon is looking like, sort of. Yeah, it's like all lit up. And then if we're going to slightly before a full moon, we'll go to May 5th, Cinco de Mayo. It's like just behind the Earth. And then a whole full moon is May 6th. Ooh, nope, I want May 6th. It is now exactly behind the Earth. And so when we're saying that we're seeing a full moon or it's fully lit up, it's because from where we are seeing the moon, it's actually that we are on this side of the Earth and the moon is rightly positioned where it's actually getting a full face of the sun and it's reflecting it back to us. And so we are seeing as it is moving from this position all the way to the first half of its cycle, it becomes a full moon. So from a waxing crescent to a full moon is the first half of its phase. And so as it's going around that side, we're seeing that it's becoming full of light. And so if we go back here, we can go from April 23rd to, which is when the new moon started, to May 6th is, as we just talked about that the way that it orbited around the Earth. See if this makes sense to you. So it's going around the Earth and now it's behind us. And so now we're seeing the whole thing. So what happens when we are continuing on the other side of the orbit back towards the sun? Well, the light will disappear and move towards another new moon, which is the start of the cycle. So we'll say on May 9th is when it's really starting to be waning gibbous, but we'll go to May 10th to see where that is. So I think it's going to be somewhere over here near Scorpius. We'll go to May 10th. Up, it's even further than that. So now is over here. So you can actually see how much it's actually moved in those 4 days, and losing all that light. And then if we go to the third quarter moon, which is May 13th, it's moved even more. And so now it's in the last quarter of its cycle. So we said the first quarter was here. So it starts here and then it moved here in the first quarter. Stop it. And then the third quarter, or the full moon, sorry, it's the second quarter, the first half, which is the full moon, and the third quarter is the third quarter moon. And then the last quarter is going to bring us back to a full moon, which will have the waning crescent on May 16th. Yes.
So we've had a couple questions. One from Charlotte. How many phases of the moon are there in total?
In total. Okay, so we have the new moon, the waxing crescent, which takes a few days, then the third quarter, which is only 1 day, the waxing gibbous, which is also a few days, and then we have the new moon. So that's 5. And then, I'm sorry, the full moon. And then we have the waning gibbous, which takes a few days, third quarter, which is 1 day, and then waning crescent, and then we're back to full moon. So I'd say 9 of steps in those phases, from start to finish or start to start. But this happens once a month. I mean, the phases are typically once a month, which is actually how we got about 30 days in each month. So yeah, there's about 12 per year. Yes.
And Margaret would like to know, how old is the moon?
Ooh, that's a good question. So I actually don't know exactly how old it is. Scientists have theorized that based off of evidence and testable guesses or testable hypotheses that were made, and we ran tests on the lunar rock samples that were brought back, and the samples that we actually have that were sent somehow back from Mars, and also just Martian meteorites that we have. We actually were able to compare the rocks. And so we actually think that a Mars-sized planet collided with Earth while the Earth was forming. And so it was like already made, but it was like on fire because of all of the rock and level of heat that was on the planet. And so they actually collided, and most of it stayed on the Earth, but a part of it may have fallen off as it was orbiting around each other, and then broke off. And so it used to be close to the Earth and it was spinning around, but as it's spinning, the orbit of the moon's actually getting a little bit further away. And we do have evidence for that, saying that as the moon continues on its orbit, it's actually moving a little bit further away. So we don't know how old the moon is. It's probably as old as the Earth, if not a little bit younger, just because the Earth formed first. But that's just the hypothesis that we have. Okay, so yes, so where was I? Oh, okay, so the 16th was the waning crescent. So again, you're seeing that there's this crescent of light, but now the moon is on the other side of the Earth and it's almost reaching this new moon phase, which I guess is May 21st. So let's go look at May 21st. And it's back over here. And so now it's in front of the Earth, sort of, and blocking that light. So what's actually interesting to know about this is that on certain times of the year, as the moon is passing in front of the Earth, between the sun and the Earth, that actually causes an eclipse, a solar eclipse. And you may remember that in 2017, I believe there was it August 23rd, 2017? Maybe it was August 24th. It was in August 2017, and at least in New Jersey, where I was at the time, we actually were able to see most of the solar eclipse. So the sun wasn't completely covered, but it was mostly covered. And people were like, why is that happening? How is it that the sun's light can just go out? Well, what happens is that as the moon was passing in front of the sun, it casted a shadow on the Earth. And so one way to actually see this is that, okay, so we'll say my phone is the sun and my face is the Earth. And so we have this little moon passing in front, and there's actually this like shadow of something in front of my face. Pretend that all you see is like this little hole. And so as it's passing in front of my face, in front of my eye, it actually blocks out the light in front of my eye. Ooh, I feel like I just went back to the eye doctor when they shine that light in your eye. And so that's actually what happens when a solar eclipse happens, that the moon is passing in front of the sun and blocking out that light. Yes, Drew.
So not a question, but just going back to the age of the moon, Emily shared that she read the moon was 4.5 billion years. Is that in the right neighborhood?
Yes, that sounds about right. So that's when the solar system formed. And that's when the sun formed and the earth formed. And so the earth formed about the same time. So that would be the moon as well. Yeah.
One other question, Margaret wants to know, why do people sometimes think they see pictures of people or rabbits in the moon?
That's a really good question. So we will take a look at that. So this thing is so confusing. Hang on, I'm gonna hide that. Okay, so I'm going to go to the hotspots and then do the lighting. And I'm gonna turn all of this off. Why is this not on? Okay, so I'm trying to find the right one. Maybe I don't have the right way that we look at it, but okay. I'm gonna stop the share for a second, and you should be seeing my face. So I'm gonna pin it so I can see what I'm doing. So when you're looking at this image, when I show it to you next, I'm gonna want you to slightly turn your head to the right. So hopefully I'm appearing that I'm tilting my head to the right. Maybe it's to the left that it seems like, but I'm tilting my head to the right, and you should be able to see it when I share my screen. So as you tilt your head to the right, it kind of looks like a rabbit, where this is the fuzzy tail, this is the behind with the leg, and then the front leg, and maybe a head here, or this can be like the eye. Personally, I don't ever see the man on the moon, but I do see a rabbit. It also just depends on like a certain time of the month where yeah, they'll think about a face on the moon or something. But really it's just about how, when you're looking at the sky, how it appears. So that was a really good question. Thank you for asking that. Yeah, so going back to the eclipse, so we said that a solar eclipse is when the moon passes in front of the earth while the sun is shining during the day. There's also another type of eclipse called a lunar eclipse. And this doesn't mean that you know, that something's happened to the moon. If we go back to, I think it was the 13th, I could be wrong. No, it was earlier than that. Was it the 10th? I said 10. Okay, maybe it was 8, whatever. So let's say this is the full moon, or no, full moon. Where's the full moon? Okay, May 6th. Great. May 6th. Let's say May 6th at night, we were observing the moon, and all of a sudden it wasn't this bright color anymore. It wasn't like this. It kind of looked more yellow or red. It actually looked more like this. So what is going on when we see this kind of color? What's actually happening is that now between the moon and the sun is the earth. And so the earth passes at just the right way, where at night the earth passes in front of the moon and it actually casts a shadow on the moon. And so just like as the moon passes from the earth in front of the sun, it casts a shadow on some parts of the earth and blocks out that light. The earth can actually block out the light to the moon, and so it's not as bright. And so part of the moon or all of the moon can appear darker, and then it passes and it goes away. It's actually really cool to see, and it happens pretty quickly, rather in the span of about an hour, sometimes 2 hours. And they're really cool to see. So yeah, that only happens when the moon is behind the earth. And then solar eclipses can only happen when the moon is passing in front of the sun. So it happens with new moons only. So that is the moon and its phases. Does anybody have any other questions? Those were some really wonderful questions, and I'd be happy to answer any more.
Yeah, so just a reminder, you can type in your questions on Facebook and we'll get a ping to answer them. Include your first name and your location if you can. And maybe I'll let Hannah provide us with a few final thoughts on the moon, maybe her favorite parts of the moon while we wait for see if we have a few more questions, although we've already had a bunch of good ones.
Yeah, so personally, my favorite parts about the moon are the Maria, like we were saying before. Let me just share this again. I think they're very special and a unique part about the moon. Ooh, I didn't know I could do that. Just moving my things you learn every day. Yeah, I really enjoy seeing the Maria. But my favorite thing has probably got to be Apollo 11, which was where the first steps on the moon were taken. And so what you're actually seeing on the right is the first step that was taken. I can't remember if this was Buzz Aldrin or Neil Armstrong's first step, but because there's not a lot of gravity on the moon, there's actually quite a lot of dust and it just sits there. So, and there's no wind because of no atmosphere, so it doesn't like blow away. So those steps are actually still there to this day, along with an old camera, I believe. An American flag is there, but it's not blowing, it's just standing there because there's no wind. So this was taken on the Sea of Tranquility, or the Tranquility Mare, which is over here. So yeah, that's something that I really enjoy because it is a piece of history. And it's the first stuff that we've learned about other places where things don't necessarily work the same way on other moons or planets that we experience here on Earth. We're a little bit different, and I quite like that. But the moon is very important to us. Without the moon, we wouldn't have waves. We wouldn't really have, we would have wind, but it does have an impact on that. Not substantial, but it does have that influence, and it also can be a guiding light. Without the moon, things would be pretty dark. So that is some good stuff. Yes.
Maybe one final question. Margaret is wondering, which planet has the most moons? I know this harkens back to our first lesson on the solar system.
Yes. So I have to remind myself. Oh man, my mouse. So the most moons, it's either Saturn or Jupiter, but I don't think that NASA's actually updated its count. I could be wrong that Jupiter has more moons, but according to NASA, there's 82 moons on Saturn, around Saturn, and 79 with Jupiter. Yeah.
All right. Well, thanks everybody for joining us today, and a warm thank you to Hannah for our third of 4 lessons. If you're missing those other classes, or maybe if you have friends who missed this one, you can head over to the Girl Scouts of the Green and White Mountains Facebook page and find recordings of all 3 of our sessions, including today's. This one will be available hopefully this weekend, shortly after we finish today. And you can also check them out on the fairbanksmuseum.org website page. Both places have downloadable handouts. So there's more work to do than just to listen to Hannah. You got to make sure you do those handouts for your badge also. So thank you again, everybody. And thank you, Hannah. And if you're a junior who's strayed onto the Facebook page right now, we'll be starting shortly at 4 o'clock with the badge for juniors. Thanks. Bye-bye.